Okay, another one of the major components of any data center is your data center storage. Now, when you hear the term data store, that's a generic term. We use that for a container, for a storage volume. Don't assume that that data store is a single hard drive, or even all the hard drives on a single computer. That data store could be composed of multiple volumes spread across multiple ESXi hosts or VMware hosts, all aggregated together for the purposes of creating massive amounts of storage. Um, Now, there are some things that data center stores need that your normal workstation storage doesn't. It needs larger storage capabilities, faster speed, more reliability, more fault tolerance. So think about the kind of fault tolerant systems you've maybe experimented with it before. In the server class, if you did a RAID array, you built some virtual hard drives and you built a RAID 5, but you were using very small drives, maybe 10 or 20 gigabytes a piece. So your total storage wasn't really all that much bigger than a single physical drive. With these kinds of things, we're talking about pushing the limits of what a file system can do. In the server class, we would have talked about things like the upper bound on what NTFS can store, and things like the redundant the resilient file system, REFS. In the Linux course, we may have talked about the B tree file system or zettabyte file system, truly massive storage file systems. Both vSphere and Hyper-V provide some high-speed, high-availability storage solutions. So we're talking very, very, very fast hard drives and lots of them. We're also talking about storage tiering. Um, Now that solid-state drives are economical, now that there's a lot more you can do with those, one thing that we can do now that solid-state drives are a real possibility is to deploy both into the bare metal computers that make up bare metal servers that make up our data center, and then teach our hypervisors to use both of them at the same time for different purposes. What this does, essentially, say for example, one host needs to write to a different host. What it will do to speed that process up is write, whether it's coming off the SSD or the HDD. When I say HDD, I mean a spinning physical disk, a spinning Rust disk, whereas SSD is obviously a solid-state drive. For the purposes of this discussion, we're going to ignore whether that HDD is IDE or SATA or SCSI or SAS. It really doesn't matter what it is because it's physical. And that physical device has some slowness built into its mechanism that the SSD is there to help us manage. So essentially, the one host needs to write to another host. What it will do essentially is take the data from wherever it is, SSD or HDD, and it will write to the SSD on the other host. And as far as it's concerned, the sending system is done. The work is done, the file is sent, the sending system takes its hand off the process. The receiving system keeps working. So because it receives the data on the SSD and it holds it, and when there's time, when it's good and ready, it will take that data and write it to the HDD, the spinning disk storage. So you have the long-term stability of spinning Rust storage, and also the speed of access of the SSD. Because of course with the SSD, it is essentially it is a solid-state system. It's NVRAM or NAND flash on steroids. We also have some things like, we can do some things like data deduplication. If you need to have if you need the same data in many places, but you don't want it to take up all that space in those many places, what you can do is have one object and then pointers back to that object. Essentially, for those of you who remember the Linux class, you've got a data duplication works by symlinking things, as it were. Those reference pointers, if you've got a background in programming, think about how you might want to return more than one variable out of a function in a programming language which only allows you to return one value. Say C, C++, Java. As far as I mean, I know C and C++ work that way. I think Java works that way as well. If you want to change more than one thing and have that change come out of that function, you have to reference. You pass a reference in and you do the work, and then the other code can reach in and grab the value. So the next thing we're going to do is we're going to talk about types of storage systems. Thank you for your patience, and we'll be right back.